Every time we connect to the internet, whether through a home broadband connection, a corporate leased line, or a remote VPN, there is always a digital handshake taking place. This handshake verifies who we are and decides whether we are allowed to access the network. On serial WAN links, this authentication process is commonly handled by something called PPP, the point-to-point protocol. Now, PPP supports two major authentication methods, PAP and CHAP. PAP is old and insecure, while CHAP is the recommended secure method. In this 10-minute video, we will break down how PPP works, why authentication is needed, and why CHAP is a huge improvement over PAP. Let's get started. PPP or point-to-point protocol is a layer 2 data link protocol. Its job is to create a reliable connection between two nodes over a serial link. It replaced older technologies like SLIP and introduced better reliability and functionality. PPP encapsulates higher layer protocols so the packets such as IP packets can be safely transmitted across point-to-point connections. PPP is used in many real-world places including dial-up, DSL, broadband, tunneling, and VPN environments. Behind the scenes, PPP is built from three primary components. LCP, Link Control Protocol. LCP handles link setup, configuration, and link quality testing. It even decides if authentication is needed and which method to use, PAP or CHCP. NCP, Network Control Protocol. After authentication, NCP configures network parameters like IP address, DNS, subnet mask. The first authentication method is PAP, Password Authentication Protocol. Now let's understand how PAP works through a simulation. We begin with the phase 1, link establishment, handled with the link control protocol. You can see the packets labeled LCP request moving from the client to server. The server responds with an LCP acknowledgement. This exchange negotiates link settings, verifies that both sides are already ready, and establish the communication channel. Only if this LCP handshake completes, does PPP move forward the authentication phase. Phase 2 is authentication. Here, the client must prove its identity to the server. In PAP, the process is very simple but also insecure. You will see red packet traveling from the client to server. This packet contains username and password in plain text without any form of encryption or hashing. If someone interrupts the packet, they can read the credentials exactly as they were sent. Once the server receives the information, it checks these credentials against its stored database. If they are correct, the server sends a green authentication acknowledgement packet back to the client, signaling successful login. With authentication complete, PPP transitions into phase 3, network control configuration, handled by IPCP, IP control protocol. In this phase, the client and server exchange IPCP packets to configure network parameters such as the IP address. In this, you will see the packets moving back and forth to represent this configuration. Once IPCP is negotiated, the PPP link is fully established and the connection is ready for data transmission. Now look at the advantages and disadvantages of PAP. Advantages: PAP is very easy to implement because it has a straightforward two-step process. It requires minimal processing power, making it suitable for older systems or very low simple devices. It can be used in environments where security is not a concern, such as internal or low-risk networks. Disadvantages: the biggest drawback is the password is sent in plain text, making it extremely vulnerable to eavesdropping. PAP provides no encryption, no challenge response mechanism, and no protection against reply attacks. If an attacker captures the authentication packet, they can directly see and reuse the credentials. Due to this weakness, PAP is considered insecure and is rarely used in modern secure networks. The more secure method is CHAP, Challenge Handshake Authentication Protocol. Now let's understand how CHAP works through a simulation. The client is shown on the left and the server on the right. Watch how the packets move between them to visualize the three-step CHAP authentication process. When authentication starts, the server sends a random challenge value to the client. This is shown in the animation as a yellow packet traveling from the server to the client. Each time login occurs, a new, unpredictable challenge is generated, which plays a key role in securing this process. Next is step 2, the response. The client takes this challenge value, combines it with password, and applies a one-way hash function. This produces a hashed output that cannot be reversed to get the original password. The blue packet moving toward the server represents the secure hash response. The actual password is never sent over the network, making CHAP far safer than PAP. Finally, we reach step 3, success verification. On receiving the hash, the server performs the same hash operation using the password it chose. If the server's calculated hash matches the client's hash, authentication is successful. This is shown when the green OK packet returns from the server to the client. This entire process forms a three-way handshake that protects the user's credentials and ensures secure communication. Now let's summarize the advantages and disadvantages of CHAP. Advantages: CHAP never sends the password over the network, only a handshake response is transmitted. It protects against the reply attacks because the challenge value changes each time authentication occurs. Even if a packet is captured, the attacker cannot recover the password from the hash. CHAP continuously verifies the client at regular intervals, increasing security. Disadvantages: CHAP requires more processing compared to PAP because hash functions must be computed by both client and server. Both sides must store the same secret password, which can be a risk if the stored password is not protected properly. It may not be supported by very old or minimal devices that only use simple authentication method. To summarize, CHAP provides a secure and reliable challenge response mechanism that protects password and prevents unauthorized access. So, the takeaway is simple. PPP is only as secure as its authentication method, and between PAP and CHAP is the clean winner. Never use PAP on public or untrusted networks. It's unsafe. Always use CHAP for secure PPP authentication. Thank you.